Algebra 1, Chapter 8, Section 9, perfect squares. So perfect squared trinomials are perfect squares of binomials. So we've talked about this before in Section 4. When we had the quantity a plus b raised to the second power, you can use the formula a squared plus 2ab plus b squared. Or if you have a minus b quantity squared, you can get a squared minus 2ab minus b squared. Well, formulas work two ways. It works from the left to the right, but it can also work right to left. For instance, a squared plus 2ab plus b squared can be broken down and factored out into a plus b times a plus c, which since we have 2a plus b's, we can simply write it as quantity a plus b raised to the second power. The same with a squared minus 2ab plus b squared. It can be factored down to a minus b times the quantity a minus b, which since we have two quantities of a minus b, we can just raise the quantity to the second power. So our lesson menu has 5 examples for us to go through after our quick check. So factor here, this is going to be an x and an 11. So since there's nothing in the middle, it's x minus 11, x plus 11. Let's see, factor. So can we break it down into perfect squares? This would be, I would need to take a negative out front. So we have nothing in the middle. If we switch it around, so it's 1 minus 36x squared, there we go. Then we have 1 minus 6x and 1 plus 6x. 1 minus 6x, 1 plus 6x. That's solving. Bring 49 over, we get 4c squared minus 49. So this would be 2c minus 7, and nothing in the middle, so 2c plus 7. So each of those equal to 0, that's how we would solve, and we would get this is equal to 0, so that's 7 divided by 2, and negative 7 divided by 2. Solving here, so again, this has an x in common, and then I can break this into 5x quantity squared minus 3 quantity squared. So this will be x times 5x minus 3 times 5x plus 3. Then x equals 0. So each one of these equals to 0. You add 3, just in case we forget. Divide by 5. X is equal to 3/5 and a negative 3/5. So 0, 3/5, and negative 3/5. B. So a square with side lengths of b is removed from a square with side lengths of 8. So removed means subtraction generally. So write an expression to compare the area of the remaining figure to the area of the original square. Okay. So I would take, okay, so we are comparing the original area to remaining. So the original, let's see, is 64, 8 times 8. And what's remaining? Well, what's remaining is when we take this out. How do we take it out? We subtract something. So we take our original area minus our little square area. So the original is length times width, 8 times 8, minus that length of b times length of b, so that's 64 minus b squared. And then we are comparing it to the original, so we put it over the original of 64. Which shows the factors of 8m to the third minus 288m. Let's take out what we have in common. So we have an 8 and an m in common, so I take out the 8m. That leaves me with m squared minus 36. I see a perfect square here and a perfect square here. So 8m, this will be m minus 6, m plus 6. Let's see, and b. We have found the product of the sum and difference, and we need to now find the perfect square trinomials and solve equations involving perfect squares. Of course, perfect square trinomial we defined earlier. We have our little key concept box here for what we are looking for, a squared plus 2ab plus b squared. So you find your a, you find your b, you multiply them times 2, and if you get the number in the middle, you know you can use this little quick way of doing it. So determine whether 25x squared minus 30x plus 9 is a perfect square trinomial. If so, factor it. So what would be the a? So 5x. What would be the b? 3. So 2 times 5x times 3, so that'll be 30x. So it can be. So when we factor it, it'll be 5x minus 3 quantity squared, a minus b quantity squared. Again, determine. So we have, this will be 7y would be your a, your b would be 6. So 7 times 6 is 42, times 2 is 84, so this is not a perfect square trinomial. Trying one on our own, we have, this would be 3x, this would be not 8, it would be 4. 4 times 3 is 12, times 2 is 24, and we have a 12 in the middle, so this is not a perfect square trinomial. Determine on this one, so we would have 7x here, we would have 2 here, 7 times 2 is 14, times 2 is 28, so it looks like it would work out, and since it's a plus here, we can say 7x plus 2 quantity squared, b. Concept summary, so factor out the GCF, so that's the first thing. If they have anything in common, take it out. Then check for a difference of squares or a perfect square trinomial, and then apply the factoring patterns accordingly. So factoring here, we have something in common. I think we have a 6 in common, so let me check. 96 divided by 6 is 16. Take that out, we're left with x minus 16, x squared minus 16. So that would be 6x minus 4, x plus 4, since we definitely don't have a trinomial going on there. It can't be a perfect square trinomial. Factoring here, so again, checking, we have 4y, so do you have anything that can be taken out? No. So we take out the square root of 16y squared is 15 is not a perfect square. So this trinomial is in the form ax squared plus bx plus c instead of ax squared plus 2ab plus b squared. So the numbers m and p is product of 16 times negative 15 or negative 40, and the sum is 8. Yes, the product of 20 and negative 12 is negative 40, and the sum is 80. So you have 3 terms. Well, the first term is a perfect square. The last one is not, therefore this is not a perfect square trinomial. It is probably factorable, as we can see here. They did it their kind of different way. We can use the window, 16y squared, and 15. 15 times 16 is 240. And you come up with your factors, 1 and 240, 2 and 120, 3 and 80, 4 and 60, 5, 4 divided by 5 and 48, 24, 240 divided by 6, 40, 240 divided by 7, no, 240 divided by 8, wait, 240 divided by 8 is 30, 240 divided by 9, 240 divided by 10 is 24. What am I trying to make again? I'm trying to make that 8. 240 divided by 11, 240 divided by 12. There we go. We would need a 12y and a 20y. We would have 4y in common, and we would have 5 in common. We would have 4y in common, and we would have 3 in common. So this would be 4y and 3, 4y and 5. And then everything, let's see, we need a positive 20 and a negative 12. A positive 20 means the 5 times the 4y is positive, and the negative 3 times the 4y is negative. That'll give us negative 15 as well. Let's see. They did grouping. Of course, you can do it this way. And they got 4y plus 5 times 4y minus 3. Just like we did. So you can do it either way. Factoring the polynomial here, they have a 3 in common. That leaves us with x squared minus 1. So that's 3x minus 1, x plus 1, 3x, so a. Let's see, do we have anything in common? We have 2. That leaves us with 2x squared plus 5x plus 3. 2, and then our window. Because it's not perfect square here, so 2x squared and 3, so that's 6. 1 and 6, 2 and 3, both of them can be 5, but only one way can they both be positive here. So we have a 2x and a 3x, so that gives us a 2x. Gives us 2x and a 3, an x and a 1. X and 1, 2x and 3. We said everything had to be positive. So 2x plus 1, 2x plus 3, so C. First, we have to bring that 81 over so that we get 4x squared plus 36x plus 81. But then we can look and see if we have anything that can be taken out of everything. 4 can go into 4, 36, can it go into 81? It cannot. 2 cannot go in there either. So then we look at it and say, do we have any perfect squares? Well, 4x squared can be 2x quantity squared. 81 can be 9. 9 quantity squared. Let's see if they make a trinomial. 2x times 9 is 18, times 2 is 36, so it works. So 2x plus 9 times 2x plus 9, or 2x plus 9 quantity squared. If we need to solve, we set each one equal to 0 and solve for x, so we get x equals negative 9 halves as our 0. Solving one on our own, they don't have anything in common. I do see that 9x squared can be 3x quantity squared. 25 can be 5 squared. So 3x times 5 is 15x times 2 is 30, so it seems to work out. It has a subtraction in the middle, so I would say we have 3x minus 5 quantity squared. We set that equal to 0. Add 5 to both sides. And we get 3x equals 5 divided by 3 on both sides. And we get x equals 5/3. That would be A. Square root property. If you square one side, you square the other, and that's how you can get x by itself. A nice little property. We have the b minus 7 quantity squared is equal to 36. Well, it's the opposite of squaring. It is square rooting, so we square root both sides. Get rid of that square root. You get b minus 7 equals plus or minus 6. Then we add 7 to both sides. So you're going to come up with 2 answers here. You're going to get 7 plus 6, which is 13, and 7 minus 6, which is 1. So that's how the roots of our equation here. The opposite of squaring is to square root. Do it to one side, do it to the other. So x equals, and just take that 9 over, negative 9 plus or minus. How do they come up with 2 square roots of 2? Inside that square root, they say is their perfect square. There's 4 times 2. The square root of 4 is 2. So that's how we get 2 square roots of 2. You can check your answer using a graphing calculator. Check y is equal to the absolute, or x, the quantity x plus 9 squared, and y equals 8 using the intersect feature. So you do both of those to see where they intersect, and what you see is they intersect here and here. Okay, solving this equation. Opposite of squaring is the square root. So we have x minus 4 equals plus or minus 5. Add 4 to both sides. So we get x equals 4 plus or minus 5. So 4 plus 5 is 9, and 4 minus 5 is negative 1. So 9 and negative 1 are 8. Solve the equation x minus 5 squared. The opposite of squaring is the square root. We have x minus 5 is equal to the square root of 15. There is no perfect square within 15. So we just add 5 over, and we can leave it as x is equal to 5 square roots of 15. Or not 5 square roots, 5 plus or minus the square root of 15. So B. Physical science, a book falls from a shelf that is 5 feet above the floor. Model for the height in feet of an object dropped from an initial height of h sub o feet is h is equal to negative 16 t squared plus that initial height, where t is the time in seconds after the object is dropped. Use this model to determine approximately how long it took for the book to reach the ground. So it started at an initial height of 5 feet. That got plugged in here. And our height afterwards is when it hits the floor at 0. So we subtract 5 from both sides, divide by negative 16. Then we're going to take the square root of both sides and get an answer in our calculator. So since a negative number does not make sense in this situation, the solution is 56/100. This means that it takes about 56/100 of a second for the book to reach the ground. So an egg falls from a window that is 10 feet. So here is our initial height above the ground. A model for the height h in feet of an object dropped from an initial height of h sub 0 feet is h equals negative 16 t squared, where t is the time in seconds after the object is dropped. Use this model to determine approximately how long it took the egg to reach the ground. The ground is at 0. Negative 16 t squared plus 10 feet. So I'll subtract 10 from both sides. So negative 10 equals negative 16 t squared. Divide by negative 16. So I get 10/16 is equal to t squared. Square root both sides. This t equals plus or minus 79/100, but a negative time does not make sense. So 79/100 of a second.